Okay, Dom, this setup is just for you. What I have here is two coils. I think you've seen these in the past. These were the ones I did that beat frequency with. So pretty much these two coils are the same ohmage. And this coil here is just hooked up to my function generator and as well as the scope. Right here on line 1. And the Jenny is over here. What I want to show you is that using a capacitor on this side here and matching the frequency so you get the same type of frequency here and here, it resonates, it gives a strong coupling in between the two. Hence, if I could have something like this in a base, something like this attached to my iPod or my cell phone, and I could just set down my cell phone and stuff beside the base, I could charge those little batteries that they have. Right, let's fire this puppy up. So, turn on the oscilloscope. Okay, first thing we're going to look at is the oscilloscope. Hopefully I can get it kind of clear on here. There's nothing there, that's a flat line. Now what I'm going to do is I'm going to turn on my oscilloscope, my function generator, and we're going to look at what it produces. Okay, although hard to see in this old camera I got, I'll turn off the lights here, and you can just look at that waveform. So you can see the one waveform flat is what our second coil is picking up, and the first waveform you see there, the alternating current, well, that's what I'm putting in right now at 8 kilohertz into that first coil. So let's turn the light on here, have a look at our coils. There we go. So that's the distance apart that we have in our coils, and this is our two channels, being channel 1, which is the first coil, which is over here again, right here, coming from the from the function generator, sine wave 8 kilohertz. Now here we have our secondary, which is hardly picking up anything at all. It's pretty much a flat line. Now I'm going to do a dual trace so we can see them both here. It's a little bit tough. So now I'm going to start adjusting the frequency here on the function generator and start to bring it up into an area it likes. Right there. Now, as you can see here, the first and the second form wave are almost equal, and our distance is still the same over here. What I find that at this tuned frequency now, if I move the two, let me just fine this up a bit. Now if I move the two coils closer together, we can see that in the second channel, or the second coil, there's a bit. Now my function generator output level is set quite low, 3 volts I believe, or 4 volts. The settings on my oscilloscope are at 5 volt dividers. So we're looking at 5 volts on the top side and about 3 volts on the bottom. Now if I turn up the volts, you see there's a direct correlation between the two waves. But now if I move closer my coils, so now we're at a distance up here, we get much better induction. Okay, now I've turned down the voltage coming out so we can study this waveform here. And what I'm going to do now is I'm going to show you how when I bring the two coils close together, the second waveform really climbs, but to a certain point, and then when they get close together, they actually start to lose voltage again. So when they touch, there's less voltage, which in a regular induction you would think there should be more. So as it gets closer, it climbs to a certain point, and now you'll see it drops. So that's with them right together. This is with them about 1 to 1.5 millimeters apart. And then I pull it out again to, there's about 1/2 inch. So it would seem that if the first coil here is in a tank circuit and oscillating at its resonant frequency, the second coil seems to lock into that frequency as long as it's the same ohmage, same capacitor over here, so it has the same resonating circuit, has an extremely good coupling between here and here to a certain point. I find this very interesting. This rate, I could have a tower or a base here and my charge here, and I can be charging here 2 volts with no problem, just what I'm putting in from my function generator.